Good morning and good afternoon at the same time. So today's rule for our logarithms, and again we're getting towards the end of our chapter, last few rules, is the power rule. This is actually the last one of our expanding rules. All right, and this one says log base b of a number m to the power of p. What we're really going to do is take this power of p and it's going to work its way out to the front. And that's it, just moves. Moves from being an exponent on the logarithm number all the way out to being just a constant number in front. So for example, log base 2 of x to the third power, this 3 is going to work its way out front. There it is, multiplied in front of the logarithm. No more exponent on the x. Disappeared. That's it. That's the rule today. So let's look at a couple of examples. So we got log base 10 of x to the fifth power. So again, what's going to happen is this 5, that power, is going to work its way out front and multiply with the log, leaving the x behind with no exponent. Well, same thing with natural logs. That exponent 8 is going to walk its way out front, multiply with the natural log. Whoa, if I could actually spell, not h, but n, and then the x would stay. Now sometimes we do put parentheses around that term, just to make sure you know that whatever you're taking the logarithm is ending, just in case, again, for example, what if we did not have the parentheses and there was like a plus 4 in the back here? Would that plus 4 be part of the logarithm or not part of the logarithm? So that's why we put the parentheses around things. So you can say, oh, okay, I see. That 4 there is nothing to do with the natural log. That's something completely separate. So that's why we put parentheses around them, if you've noticed that. Right. Now let's mix some of our rules from this week. Because again, these rules themselves are pretty easy, especially this one. Doesn't really have to do anything. You just move an exponent out to the front. But what if there's other stuff? How do we do it? What do we do? Well, we kind of want to go in the order that we learned the things. Basically, we want to save that exponent rule for last. All right, so let's first off, if you remember, anytime we're multiplying things, like in this first example, we're multiplying the 5 times the x. Remember we learned how that we could split that out. Multiplying can be split out with adding. Use the same log and the same base, but I split out the 5 and the x squared. All right? And then we just learned what's going to happen to this 2. It's going to move out front. But it needs to move out front of the one that it's with, the log x. It needs to be with that one, not with the 5. That exponent 2 wasn't with the 5, so it doesn't go in front of the one with the 5. It goes in front of the one with the log x. So that means we're going to end up with log base 3 of 5 plus, whoops, I forgot the 2, 2 log base 3 of x. And there is our final answer. Again, a combination of the rules, and we want to follow them in the order that we learned them. Again, saving that exponent part until after we've split things up. All right, so same thing with this next one here. What we want to do is we want to take this division problem and split it into 2 parts. So if you remember, that's going to be log base 5 of the numerator. Numerator has to come first, and then minus log base 5 of the denominator. Now I take that exponent and move it out front. But I have to split it out first so that I don't put that exponent 2 with the wrong piece. That exponent 2 has nothing to do with the 7, so it shouldn't be with the log that's of 7. It should be the log of x. So that means my answer will be 2 log 5 of x. No more exponent, it went out front. Minus log base 5 of 7. So again, combining the rules, making things a little bit tougher. Let's try just a few more. All right, next one. Once again, we want to do the multiply-divide rule, splitting it up before we deal with that exponent 3. So this division is going to break up into log base 10 of 100, and then it's division, so that's minus log base 10 of x to the third power. And then, of course, we now know that this x to the third power, that 3 needs to move out front. But that's not the only thing we can do here. Because it's a log base 10, we can get the answer to this part. That can be replaced with the number 2. If you don't remember, here's why. Remember, log base 10 of 100 equals some number. Now if I rewrote an exponent form, that base is 10, the exponent is x, and the answer is 100. 10 to what power equals 100? Well, I can't write. It's 10 to the second power that makes 100. So that missing number we would be looking for is 2. So this whole thing that I circled here gets replaced with the whole number 2. And then minus, now move the 3 out in front of the log. 3 log x. 2 minus 3 log x. So again, a little bit trickier now that we're combining the rules. They were pretty simple on their own. All right, last one, same idea. Do the multiply, divide, split before you deal with any exponents. So again, natural log, numerator first. The division turns into subtraction. And then natural log denominator. Now each piece has an exponent that needs moved out front. And again, you need the right piece with the right letter. The x had the exponent 2, so it should be the one with the 2 out front. And then the y had an exponent 3, so it should be the one with the 3 out front. So again, easy rule today, but a little trickier when you start blending the rules together. So you're going to have that pattern or that order. So again, deal with the multiply or divide rule first, then deal with that power rule after it's been split. So again, in the order that we learned them. That's why we did them in that order. All right, good luck today. Let me know if you need any help.